The intersection of metaphor, cognition, and artificial intelligence. Introduction. Metaphor is a pervasive and essential aspect of human language and cognition. It allows us to express abstract concepts, emotions, and experiences in terms of more concrete and familiar domains. From everyday conversations to literary and artistic expressions, metaphors shape the way we think, communicate, and make sense of the world around us. However, the complexity and nuances of metaphorical language pose significant challenges for artificial intelligence, AI, and natural language processing, NLP, systems. As AI continues to advance and aims to replicate human-like language understanding and generation, it is crucial to address the current limitations in handling metaphors. Traditional rule-based and statistical approaches in NLP often struggle to capture the deeper semantic and conceptual mappings that underlie metaphorical expressions. This limitation hinders the development of more sophisticated and human-like AI systems that can engage in creative and figurative language use. To bridge this gap, it is necessary to explore the cognitive mechanisms that enable humans to create, comprehend, and interpret metaphors. By drawing insights from fields such as cognitive linguistics, neuroscience, and psychology, we can better understand the mental processes and representations involved in metaphorical thinking. This interdisciplinary approach can inform the development of AI architectures and algorithms that can more effectively process and generate metaphorical language. The thesis of this paper is that exploring the cognitive mechanisms of metaphor is crucial for advancing AI's ability to understand and generate figurative language. By examining the theories, current approaches, and future directions in this intersection of metaphor, cognition, and AI, we aim to shed light on the challenges and opportunities in creating more human-like and creative AI systems. This paper will delve into the role of metaphor in cognition, its treatment in NLP and AI, case studies and applications, and the future directions and challenges in this field. 2. Metaphor and cognition. Metaphor plays a central role in human cognition, serving as a bridge between abstract concepts and concrete experiences. It allows us to create mental representations and abstractions by mapping knowledge from a familiar source domain onto a less familiar target domain. This cognitive process enables us to understand and express complex ideas, emotions, and experiences in terms of more accessible and embodied concepts. Theories of metaphor processing have evolved over time, seeking to explain how the brain creates, comprehends, and interprets metaphorical language. One prominent framework is the conceptual metaphor theory, CMT, proposed by George Lakoff and Mark Johnson. CMT suggests that metaphors are not merely linguistic devices but are deeply rooted in our conceptual system. According to this theory, we think metaphorically by using conceptual mappings that structure our understanding of abstract domains in terms of more concrete ones. For example, the conceptual metaphor love as a journey allows us to understand and reason about the abstract concept of love using the more tangible domain of journeys. Another influential theory is the image schema theory, which emphasizes the role of embodied experiences in shaping our conceptual structures. Image schemas are preconceptual patterns that arise from our sensory-motor interactions with the world, such as container, path, and balance. These schemas serve as the foundation for metaphorical mappings, enabling us to project the structure and logic of bodily experiences onto abstract domains. Recent advancements in neuroscience have shed light on the neural basis of metaphor comprehension. Studies using neuroimaging techniques have revealed that processing metaphors engages a distributed network of brain regions, including areas involved in language, memory, and sensory-motor processing. The involvement of sensory-motor regions suggests that understanding metaphors relies on simulating or reenacting the bodily experiences associated with the source domain. Metaphor is also closely linked to creativity and imaginative thinking. The ability to create and comprehend novel metaphors requires a flexible and associative cognitive process that goes beyond literal language processing. Metaphorical thinking allows us to establish connections between seemingly disparate concepts, leading to new insights, problem-solving strategies, and creative expressions. Understanding the cognitive mechanisms of metaphor is essential for developing AI systems that can effectively process and generate figurative language. By incorporating insights from cognitive linguistics, AI researchers can design architectures and algorithms that mirror the human capacity for metaphorical thinking. This involves capturing the conceptual mappings, image schemas, and embodied simulations that underlie metaphor comprehension and production. However, modeling metaphor in AI systems poses significant challenges. Metaphors often rely on implicit knowledge, cultural experiences, and context-dependent interpretations, which can be difficult to formalize and integrate into computational models. Additionally, the open-ended nature of metaphorical language requires AI systems to handle ambiguity, creativity, and novel associations. Despite these challenges, exploring the intersection of metaphor and cognition holds great promise for advancing AI's language capabilities. By drawing inspiration from human cognition and incorporating theories like CMT and image schema theory, researchers can develop AI systems that can better understand, generate, and reason with metaphorical language. This will enable more natural and expressive human-computer interactions and pave the way for AI systems that can engage in creative and figurative language use. 3. Metaphor in natural language processing and AI. Metaphor poses significant challenges for natural language processing, NLP, and artificial intelligence, AI, systems. Traditional approaches in NLP often rely on literal and compositional meaning, struggling to capture the figurative and non-literal aspects of metaphorical language. However, recent advancements in NLP techniques and AI architectures have paved the way for more sophisticated handling of metaphors. One current approach to processing metaphors in NLP is the Metaphor Identification Procedure, MIP. MIP aims to automatically identify metaphorical expressions in text by analyzing the contextual and semantic properties of words and phrases. This procedure typically involves steps such as part-of-speech tagging, word sense disambiguation, and semantic similarity measures. By identifying potential metaphorical candidates, MIP helps in the initial stages of metaphor processing pipelines. Another approach that has gained attention is computational stylistics, which focuses on analyzing the linguistic style and figurative devices used in text. Computational stylistics employs techniques from natural language processing, machine learning, and statistical analysis to identify and characterize metaphorical patterns. This approach can help in understanding the rhetorical and stylistic functions of metaphors in various domains, such as literature, political discourse, and social media. Despite these advancements, existing AI systems still face limitations in comprehending and generating metaphorical language. One key challenge is the lack of common sense knowledge and real-world understanding that humans possess. Metaphors often rely on shared experiences, cultural references, and contextual cues that are difficult to encode in AI systems. Additionally, the open-ended nature of metaphorical interpretations and the potential for novel and creative metaphors pose challenges for rule-based and statistical approaches. To address these limitations, researchers have explored the concept of computational dreaming as a potential avenue for metaphor processing in AI. Computational dreaming involves designing AI systems that can simulate or mimic the imaginative and associative processes that occur during human dreaming. By enabling AI to generate and explore novel connections and mappings between concepts, computational dreaming could potentially enhance the system's ability to understand and generate metaphorical language. Integrating insights from cognitive linguistics into AI architectures is another promising approach. Cognitive linguistic theories, such as conceptual metaphor theory and image schema theory, provide a framework for understanding the conceptual mappings and embodied experiences that underlie metaphorical thinking. By incorporating these theories into AI models, researchers aim to develop systems that can better capture the semantic and conceptual representations necessary for processing metaphors. For example, researchers have explored the use of conceptual spaces and semantic networks to represent metaphorical mappings in AI systems. These approaches aim to capture the relationships and associations between concepts, enabling the system to reason about metaphorical connections. Additionally, the use of deep learning techniques, such as recurrent neural networks and transformer models, has shown promise in capturing the contextual and semantic dependencies involved in metaphorical language. Another area of research is the development of AI systems that can adapt to novel metaphors and figurative expressions. This involves designing architectures that can learn and generalize from examples, allowing the system to handle previously unseen metaphorical mappings. Techniques such as transfer learning and few-shot learning have been explored to enable AI systems to quickly adapt to new metaphorical contexts. While significant progress has been made in the intersection of metaphor and AI, there are still ongoing challenges and future directions to be addressed. One key challenge is bridging the gap between symbolic and neural representations of metaphor. Integrating the structured knowledge and reasoning capabilities of symbolic AI with the flexibility and adaptability of neural networks is an active area of research. Additionally, incorporating context and world knowledge remains a crucial challenge in metaphor processing. AI systems need to be able to leverage vast amounts of background information and common sense knowledge to accurately interpret and generate metaphorical expressions. This requires the development of large-scale knowledge bases and the integration of external knowledge into AI architectures. As AI systems become more proficient in handling metaphorical language, ethical considerations also come into play. Metaphors can carry cultural biases, stereotypes, and persuasive power. Ensuring that AI systems use metaphorical language responsibly and avoid perpetuating harmful biases is an important consideration for future research and development. In summary, metaphor processing in NLP and AI has made significant strides, but challenges remain. Integrating insights from cognitive linguistics, exploring computational dreaming, and developing adaptive and context-aware AI architectures are promising avenues for advancing the field. By bridging the gap between human cognition and AI, we can move closer to creating systems that can effectively understand, generate, and engage with the richness and creativity of metaphorical language. 4. Case studies and applications. The intersection of metaphor, cognition, and artificial intelligence has given rise to various case studies and applications that demonstrate the potential and challenges of processing metaphorical language in real-world scenarios. These case studies span across different domains and highlight the practical implications of integrating metaphor understanding into AI systems. One notable example is the work conducted by the Metaphor Lab Amsterdam, led by Gerard Steen. The lab focuses on the interdisciplinary study of metaphor, combining insights from linguistics, psychology, and computational approaches. Their research involves the development of metaphor annotation schemes, corpus analysis, and computational models for metaphor identification and interpretation. The Metaphor Lab Amsterdam has contributed to the advancement of metaphor analytics, providing valuable resources and tools for researchers and practitioners working on metaphor processing. Another application area is the modeling of metaphor comprehension in conversational AI agents. As virtual assistants and chatbots become increasingly prevalent, the ability to understand and generate metaphorical language is crucial for more natural and engaging human-computer interactions. Researchers have explored various approaches to integrate metaphor processing capabilities into conversational AI systems. For example, some studies have focused on developing dialogue models that can recognize and interpret metaphorical expressions in user queries and generate appropriate responses. These models often combine techniques from natural language processing, machine learning, and knowledge representation to handle the complexity of metaphorical language in conversational contexts. In the field of natural language generation, metaphor has also received attention as a means to enhance the creativity and expressiveness of AI-generated text. Researchers have investigated methods to generate metaphorical language in various applications, such as poetry composition, story generation, and content creation. One approach is to leverage large-scale language models and fine-tune them on datasets rich in metaphorical expressions. By training on diverse examples of metaphorical language, these models can learn to generate novel and creative metaphors. Another approach is to incorporate explicit metaphor generation modules into the language generation pipeline, using techniques such as conceptual blending and analogy-based reasoning to produce figurative expressions. Metaphor processing also plays a crucial role in cross-cultural communication and machine translation. Metaphors are deeply rooted in cultural experiences and often carry culturally specific meanings and connotations. When translating metaphorical expressions from one language to another, AI systems need to consider the cultural context and find appropriate equivalents in the target language. Researchers have explored techniques, such as cross-lingual metaphor mapping and cultural adaptation to improve the accuracy and fluency of machine translation systems in handling metaphorical language. By incorporating cultural knowledge and adapting metaphors to the target language and culture, AI systems can facilitate more effective cross-cultural communication. In the domain of education and language learning, metaphor processing can be applied to develop intelligent tutoring systems and language learning tools. Metaphorical language is often used in educational materials, such as textbooks and lectures, to explain complex concepts and engage learners. AI-based tutoring systems can benefit from the ability to recognize and explain metaphorical expressions, providing personalized guidance and feedback to students. Additionally, language learning applications can incorporate metaphor processing to help learners understand and produce figurative language in their target language, enhancing their linguistic competence and cultural understanding. These case studies and applications highlight the diverse range of scenarios where metaphor processing in AI can have a significant impact. From metaphor analytics and conversational AI to natural language generation and cross-cultural communication, the integration of metaphor understanding and generation capabilities opens up new possibilities for more advanced and human-like AI systems. However, it is important to acknowledge the challenges and limitations associated with these applications. Metaphor processing in real-world contexts often requires dealing with ambiguity, context dependency, and cultural nuances. AI systems need to be able to handle the open-ended nature of metaphorical interpretations and adapt to different domains and user preferences. Additionally, the ethical considerations surrounding the use of metaphorical language in AI systems, such as the potential for biased or offensive expressions, need to be carefully addressed. Despite these challenges, the case studies and applications discussed demonstrate the potential of integrating metaphor processing into AI systems. By leveraging insights from cognitive linguistics, computational approaches, and interdisciplinary collaborations, researchers and practitioners can continue to push the boundaries of what is possible in the intersection of metaphor, cognition, and artificial intelligence. As AI systems become more adept at understanding and generating metaphorical language, they can contribute to more natural, creative, and culturally sensitive human-computer interactions across various domains. The future directions and challenges. The field of metaphor processing in artificial intelligence is rapidly evolving, presenting both exciting opportunities and significant challenges. As researchers continue to explore the intersection of metaphor, cognition, and AI, several future directions and challenges emerge. One key challenge is bridging the gap between symbolic and neural representations of metaphor. Traditional symbolic approaches to metaphor processing relied on handcrafted rules and knowledge bases, which often struggled to capture the flexibility and context sensitivity of metaphorical language. On the other hand, neural network-based approaches, such as deep learning models, have shown promise in learning metaphorical patterns from large amounts of data. However, these models often lack the interpretability and explicit reasoning capabilities of symbolic systems. Integrating the strengths of both symbolic and neural representations is an important direction for future research. Developing hybrid approaches that combine the structure and reasoning of symbolic AI with the adaptability and learning capabilities of neural networks could lead to more robust and comprehensive metaphor processing systems. Another challenge lies in incorporating context and world knowledge into metaphor interpretation. Metaphors often rely on a shared understanding of the world, cultural background, and situational context. For AI systems to accurately interpret and generate metaphorical language, they need to have access to vast amounts of common sense knowledge and be able to reason about the contextual factors that influence metaphorical meaning. This requires the development of large-scale knowledge bases that capture the diverse range of human experiences, beliefs, and cultural norms. Additionally, AI systems need to be able to dynamically integrate and apply this knowledge in a context-sensitive manner. Research efforts in areas such as knowledge representation, common sense reasoning, and contextual modeling will be crucial in advancing AI's ability to handle metaphorical language in real-world scenarios. The open-ended nature of metaphorical language poses another significant challenge. Metaphors are not fixed or predefined, they can be created on the fly, drawing from a wide range of conceptual domains and experiences. AI systems need to be able to adapt to novel metaphors and figurative expressions that may not have been encountered during training. This requires the development of flexible and adaptive AI architectures that can learn and generalize from limited examples. Techniques such as few-shot learning, meta-learning, and transfer learning could be explored to enable AI systems to quickly grasp and interpret new metaphorical mappings. Additionally, incorporating creativity and imagination into AI systems, possibly through approaches like computational dreaming, could help in generating novel and meaningful metaphors. As AI systems become more proficient in processing metaphorical language, ethical considerations come to the forefront. Metaphors are powerful tools for shaping perceptions, influencing opinions, and evoking emotions. They can also carry cultural biases, stereotypes, and potentially harmful connotations. Developing AI systems that can use metaphorical language responsibly and avoid perpetuating or amplifying biases is a critical challenge. Researchers need to address questions of fairness, transparency, and accountability in metaphor processing systems. This may involve techniques such as bias detection, explainable AI, and ethical frameworks that guide the generation and interpretation of metaphorical language. Interdisciplinary collaboration will be essential in addressing these challenges and advancing the field of metaphor processing in AI. Combining insights from cognitive science, linguistics, philosophy, and computer science can provide a more comprehensive understanding of the cognitive mechanisms underlying metaphor and inform the design of AI systems. Collaborations between researchers, industry practitioners, and domain experts can foster the development of practical applications and ensure the responsible deployment of metaphor processing technologies. Looking ahead, the integration of metaphor processing capabilities into AI systems has the potential to revolutionize various domains. In creative industries, such as advertising, entertainment, and design, AI-assisted metaphor generation could inspire new ideas and enhance the impact of communication. In education and training, metaphor-aware AI tutors could provide personalized explanations and analogies to facilitate learning. In healthcare, metaphor processing could aid in doctor-patient communication, making complex medical information more accessible and relatable. As research progresses, it is important to consider the broader implications of metaphor processing in AI. Will AI systems eventually surpass human creativity in generating novel and meaningful metaphors? How will the widespread use of metaphorical language by AI impact human cognition and communication? These questions open up avenues for philosophical and societal reflections on the future of human-AI interaction. In conclusion, the future of metaphor processing in AI presents both exciting possibilities and significant challenges. Bridging symbolic and neural representations, incorporating context and world knowledge, adapting to novel metaphors, and addressing ethical considerations are among the key areas that require further research and development. Through interdisciplinary collaboration and responsible innovation, the field of metaphor processing in AI has the potential to unlock new frontiers in human-like language understanding and generation, ultimately enriching human-AI communication and creative expression. Conclusion? In this paper, we have explored the fascinating intersection of metaphor, cognition, and artificial intelligence. Metaphor, as a fundamental aspect of human language and thought, poses significant challenges for AI systems in terms of understanding and generating figurative language. However, by drawing insights from cognitive linguistics, neuroscience, and psychology, researchers are making strides in developing AI systems that can effectively process and engage with metaphorical expressions. We have seen that metaphor is not merely a linguistic device but a cognitive mechanism that shapes our understanding of abstract concepts and experiences. Theories such as conceptual metaphor theory and image schema theory provide valuable frameworks for modeling the conceptual mappings and embodied knowledge that underlie metaphorical thinking. Incorporating these theoretical foundations into AI architectures can lead to more human-like language processing capabilities. The case studies and applications discussed highlight the potential impact of metaphor processing in various domains, from conversational AI and natural language generation to cross-cultural communication and education. These examples demonstrate the practical value of integrating metaphor understanding and generation into AI systems, enabling more natural, creative, and culturally sensitive human-computer interactions. However, we have also acknowledged the challenges and future directions in this field. Bridging the gap between symbolic and neural representations, incorporating context and world knowledge, adapting to novel metaphors, and addressing ethical considerations are among the key areas that require ongoing research and development. Interdisciplinary collaboration and responsible innovation will be crucial in advancing the field, and ensuring the beneficial deployment of metaphor processing technologies. The importance of interdisciplinary research cannot be overstated. Metaphor processing in AI sits at the intersection of multiple fields, including linguistics, cognitive science, computer science, and philosophy. By fostering collaboration and knowledge exchange among researchers from diverse backgrounds, we can gain a more comprehensive understanding of the cognitive mechanisms underlying metaphor and develop AI systems that more closely mirror human language capabilities. As AI systems become more adept at processing and generating metaphorical language, the implications for the future of human-computer interaction and artificial general intelligence are significant. Metaphor-aware AI systems have the potential to engage in more creative, expressive, and empathetic communication with humans. They can assist in tasks that require figurative language understanding, such as language translation, content creation, and sentiment analysis. Moreover, the ability to process metaphorical language may be a stepping stone towards developing AI systems with more general cognitive capabilities, such as reasoning, imagination, and abstraction. However, as we continue to push the boundaries of what is possible in the intersection of metaphor, cognition, and AI, it is crucial to consider the ethical and societal implications. The development and deployment of metaphor processing technologies should be guided by principles of fairness, transparency, and accountability. Researchers and practitioners have a responsibility to address potential biases and ensure that AI systems use metaphorical language in a way that promotes inclusivity, respect, and social good. In conclusion, the intersection of metaphor, cognition, and artificial intelligence presents a rich and promising area of research. By leveraging insights from cognitive linguistics and integrating them into AI architectures, we can develop systems that can understand, generate, and engage with the complexity and creativity of metaphorical language. While challenges remain, the potential benefits of metaphor processing in AI are vast, ranging from more natural human-computer interaction to enhanced creative expression and problem-solving abilities. As we continue to explore this interdisciplinary field, it is important to approach it with a sense of responsibility, collaboration, and openness to the insights that can emerge from the interplay of metaphor, human cognition, and artificial intelligence.